This conference will now be recorded.
Good evening, ma'am.
Good evening. Today we'll start with preparation of nitrogen, and after that there will be a discussion regarding its chemical properties and how it is reacting with other elements. And after that there will be some related problems, oxides of nitrogen, and another two important compounds of nitrogen, which is ammonia and nitric acid. Preparation of nitrogen. So see, this is the structure of nitrogen molecule, which is diatomic. And nitrogen, if we consider the outermost electronic configuration, it is 2s2 2p3. That means total 5 valence electron. Now out of these 5 valence electron, 3 electrons will be used for bond formation with the second nitrogen atom, and rest of the 2 electrons that will be used as lone pair. So 3 different bonds are there, multiple bonds present between 2 nitrogen atom, and here one of the bond is sigma bond, other 2 bonds are pi bond. Now if we consider its preparation, dinitrogen is produced commercially, that is a large scale preparation, by liquefaction and fractional distillation of air, because we know in air nitrogen is present around 80%. Okay, so very large percentage of air is basically nitrogen. So that is why if we can convert air to liquid, that means liquefaction of air first, after that it will be fractional distillation. Now why it is fractional distillation? Because here in air there is also presence of other gases, oxygen, carbon dioxide. So we want only nitrogen, which is 80%. So that is why, to remove the other impure gases, because we are trying to purify nitrogen, we are trying to separate nitrogen. Nitrogen is already present, we are not making it, but we are basically separating it from the other gases. So that is why we have to do fractional distillation. Now its boiling point 77.2 Kelvin. In terms of degree centigrade, it is negative, obviously. So it is very low, because under normal condition it remains as a gaseous form. So that is why when you are converting it to liquid, obviously it will be very low. So boiling point is 77 Kelvin, and if we compare with the boiling point of liquid oxygen, it is 90 K. So obviously liquid nitrogen will be distilling fast, and liquid oxygen that will be remaining in the vessel. Now there is laboratory method also, that is small scale preparation we can do, starting from the mixture of ammonium chloride and sodium nitrite, these two salts of nitrogen. Here nitrogen gas is produced and water, NaCl, these are the byproducts. Another method is thermal decomposition of this ammonium dichromate salt, NH4(2) Cr2O7. If we are heating this salt, then also there is production of nitrogen gas and water and chromium oxide. And the third method, by which, why it is important, because from this method you can get the most pure form of nitrogen gas. So sometimes there is question that by which method we can get pure nitrogen gas, and the answer will be it is decomposition of barium azide or sodium azide. Barium is from group 2, so its oxidation state is 2+. So here total negative charge will be 2-. Now we have 2 N3, N3(2). That means each N3 that will carry single negative charge. So this is known as basically azide. 3 nitrogen atom carrying negative charge, and there is another similar type of anion, don't be confused between these two, which is N3- charge. Now this is nitrite, these two are not same. Here we have -1 charge, 3 nitrogen atom, but here we have -3 charge. That is the difference. So this is barium azide and this is sodium azide, and -1 charge, it is +1. When we are heating it, we are getting the metal, barium and sodium, and nitrogen gas. Okay, so this method is important because we can get very pure form of nitrogen gas from this last method. Properties of nitrogen. First we will see some physical properties. This gas is colorless, odorless, tasteless, and non-toxic. It has two stable isotopes. One is 14 nitrogen, another one is 15 nitrogen. Isotope means same number of atomic number, same proton number, but difference in neutron number. So that is why mass number is different, because mass number is sum of N and P, that is proton plus neutron. But P is fixed, N is different, so that is why mass number is also different. So atomic number is same, which is 7, but because of difference in neutron number, there is difference in mass number. So two isotopes are there, though this is it remains in higher percentage. Okay. It has very low solubility in water and freezing point -210 centigrade, boiling point around -195. So you have seen it is in terms of Kelvin, 77 Kelvin. So if we convert it to degree centigrade, it will be -195.8 degree centigrade. So very low temperature. So if we have liquid nitrogen, that means we are having this temperature. Inert at room temperature. Now the reason behind its non-reactiveness, it is basically the high bond energy of this NN bond. So there is 3 bonds present between 2 nitrogen atoms. So if we want to nitrogen to take part in reaction, this bond we have to break, and for this we have to provide very high temperature. So that is the reason, as bond energy is very high, to break this multiple bond we have to provide very high energy. So that is the reason that at room temperature it is mainly inert gas. It doesn't take part in reaction, but if you want to take part in that it will take part in reaction, then you have to provide very high temperature. So when it is high temperature, it can combine directly with some metals and it forms ionic nitride. Remember, nitride ion we have just seen in the previous slide. Azide is N3, that is 3 nitrogen atom carrying single negative charge. But when we are talking about nitride, it means it is carrying 3 negative charge. Okay. So magnesium directly reacting with nitrogen. We also have some other S block metals, lithium, calcium, and also one P block metal, which is aluminium. All are reacting with nitrogen. Common oxidation state of group 2 metals +2. So it is +2, it is +2. That is, here it is 0, but after bond compound formation, it will be +2 oxidation state. So 3 magnesium, that means total positive charge is +6, and each nitrogen is carrying -3, that means -3 into 2, total negative charge -6. So as a whole, the molecule is neutral. So this molecule is magnesium nitride, then Ca3N2 calcium nitride. And when it is lithium, which is from group 1, it can have oxidation state +1. Now see, the formula is different because nitrogen is carrying 3 negative charge. So there must be total 3 positive charge, and each lithium is +1. So that is why 3 lithium atoms must be there. So the formula is now different, Li3N. But when it is group 2 metals, it is formula is Mg3N2, Ca3N2, like this. And aluminium, which is from group 13, that is P block. Here aluminium common oxidation state group 13 is +3. So that is why here, that is, it will lost all its valence electron and it can have +3 oxidation state. Now see, the formula is ALN. That means it is 1:1. Atomic ratio is 1:1 in the formula, because 3 negative charge, that will be balanced by 3 positive charge. Okay. Reaction with calcium carbide. Okay, now why it is important? Because when nitrogen reacts with calcium carbide, that is CaC2, there is formation of calcium cyanamide. This ion is known as cyanamide. Okay, now this cyanamide, now reaction with water, it forms calcium carbonate and ammonia. So this mixture, that is nitroline, mixture of CaCN2 and CaNCN, both are actually same. Here it is both the nitrogens are written together, that is, it is CaCN2. So this mixture of CaCN2 and carbon, that is known as nitroline, which is formed at very high temperature, around 1000 degrees centigrade, when you are mixing these two. Okay, but this is why it is important, because it is used as fertilizer. So directly it is not a fertilizer. In presence of water, this compound forms ammonia, which is actual fertilizer, ammonia. Okay, so that is why it is important. Now question may be there that what is mixture of nitrogen, that is which are the compounds that are present in nitrogen mixture. So the answer will be CaCN2 and carbon. Fine. Now NCN, that is cyanamide, this anion is this type of structure, 2 negative charge, and that will be balanced by 2 positive charge of calcium. Similarly, if you consider the structure of CaC2, it is basically this type of anion is present, that is carbide, and 2 negative charge balanced by 2 positive charge of calcium. Okay. Reaction with hydrogen, it combines with hydrogen, but again you have to provide high temperature, because we have to break the multiple bond present between 2 nitrogen atoms. And this reaction requires catalyst, and this is very important reaction, because by this method you can make ammonia, and ammonia is very important reagent, that is, which is also one of the compound of nitrogen, and the process is known as Haber's process. Then reaction with oxygen, again very high temperature, 2000 Kelvin. Okay, because here we have to break the double bond present between oxygen, and also we have to break the triple bond present between 2 nitrogen. So ultimately we are getting nitric oxide. So in this slide you can see how nitrogen is making nitroline, how it is directly reacting with metals, then reaction with hydrogen, reaction with oxygen. So is there any doubt? Should I repeat it once more? Uses of nitrogen. Nitrogen is having actually very versatile applications. Okay, chemical industry, if we consider, it uses the gas in the production of fertilizer. You have already seen how we have made nitrogen, also nylon, then production of nitric acid, different dyes of nitrogen, medicine, because in medicine there is presence of nitrogen, so nitrogen gas can be used as the source of nitrogen. Okay, and some explosives. Liquid nitrogen, remember the boiling point, it is very low, minus 195 degrees centigrade. So it is very low temperature. So that is why it can be used as refrigerant when we are transporting food stuff and freezing purpose, because when we are transporting it, it has to be carried for long time. So it must be present at low temperature, and this low temperature we can achieve by using liquid nitrogen. It can also be used for preservative when we are trying to preserve some specimen in biology sample. It is used to create inert atmosphere when we are trying to do some chemical reactions. So suppose we are doing some chemical reactions, and that chemical reaction you cannot perform in presence of air, because some reactions are there which you cannot do in presence of oxygen. So that means you cannot do in presence of air. So in that case, you have to create some inert atmosphere. So what we do, we remove the air and we keep nitrogen in that case, because nitrogen, it is very inert in nature, it will not take part in reaction. So that is why to create inert atmosphere we can use nitrogen. In electrical industry, nitrogen is used to prevent oxidation and other chemical reactions. Again, it is provide, that is, instead of to remove the environment of air, you can provide this gas because it is not taking part in reaction. It is very inert in nature. To pressurize cable jacket and to shield motors. Then nitrogen finds application in metal industry, in welding, soldering, brazing. All these processes are basically joining of two metals, basically. And when in building construction, these processes are used, and nitrogen is has application there. It prevents oxidation because nitrogen can replace air, and when air is not present, oxidation is also not possible. Then carbonization, decarbonization. Carbonization means incorporation of carbon, and decarbonization is de-incorporation of carbon. As a non-reactive gas, it is employed to make foamed or expanded rubber. So if we want to make expanded rubber, there must be presence of some inert gas, because oxygen, if it is present, there may be some chance of reaction, but we need some non-reactive gas, and nitrogen is very good for this purpose. Okay. Propellant gas for aerosol can, and to pressurize liquid propellant for reaction jets. So basically, if you see that all these applications, the main reason why it has so much versatile application, it is because of its inert nature. It doesn't take part in reaction so easily because of the multiple bond that is present between two nitrogen atoms. So high bond enthalpy. So that is the reason it is inert in nature and has versatile applications. Okay. Now nitrogen, it has different types of oxides, which you will not find in case of other members of group 15 elements. That is, if we consider phosphorus, arsenic, antimony, hardly you can find two types of oxide. One is the type E2O3, where oxidation state is +3. Another type will be E2O5, where oxidation state is +5. But for nitrogen, it is not restricted to these two types of formula. You can find some other types of oxides also. And the reason behind it, that nitrogen can form pi bond with oxygen. Both will be using 2p orbital, because both are from second period, there will be proper matching. And as 2p orbital, it is not so diffused, unlike the large size p orbitals like 3p or 4p. So very effective pi bonding possible. So the first oxide here we have N2O, which is known as dinitrogen monoxide, but normally we call it nitrous oxide. It is also known as laughing gas. And how we can make it? Starting from ammonium nitrate, if we are heating it, there will be decomposition and formation of this oxide. Now here you can see the structure, NN triple bond, then there is a coordinate bond attached between nitrogen and oxygen. This is linear polar molecule. This is colorless gas. It is gaseous in nature. Okay. This is also not very reactive, diamagnetic in nature, neutral to litmus. Now, one thing we have to be careful, that though it is non-metallic oxide, we know that metallic oxides are basic in nature, non-metallic oxides are acidic in nature, but that is not always true, because if oxidation state is very low, then even if it is non-metallic oxide, then also it will not be acidic. It is actually neutral. So here oxidation state of nitrogen is +1, because we have one oxygen atom which is carrying 2 negative charge. So for each nitrogen it is +1. As oxidation state is very low, so that is why it is non-metallic. It is neutral in nature. It is not acidic. Now here we can see the other resonance structures that are possible. The first structure, 1, then 2, then 3. Now among these three, it can be asked that you have to arrange them according to stability. Now here the first one is actually most stable. And why it is most stable? Because here negative charge is present over oxygen, and oxygen is more electronegative than nitrogen. So obviously it will prefer negative charge. So that is why it is most stable. Then the second one, here negative charge is present over nitrogen. And in the last one, negative charge is present over nitrogen, but oxygen is positively charged. So that is why it is most unstable, because oxygen, first of all, it is more electronegative than nitrogen. So it will prefer negative charge, but negative charge is not present. And the second reason is two positive charge side by side. That means there will be repulsion. So because of these reasons, the last structure is most unstable. First structure is most stable, and the second one having intermediate stability. Fine. Next oxide, NO, that is nitric oxide. Here oxidation state is +2. It is also called nitrogen monoxide. Now look at the structure. Nitrogen, it has 5 valence electron. 2 electrons will be used for bond formation with oxygen. 2 electrons non-bonding, that means it is lone pair. And this electron is basically single electron, that is sole electron. Fine. So this molecule is basically odd electron molecule. Remember, it is odd electron molecule. Fine. And that is the reason that it is paramagnetic in nature. This is also neutral because their oxidation state is also not very high. Colorless gas. How you can make it? Starting from copper and HNO3, copper nitrate and NO is produced, and ammonia when reacts with oxygen in presence of platinum catalyst and 900 degrees centigrade, then also this gas is produced. The number 3 is nitrogen dioxide. Now this is brown colored gas. Now we have color. The first two are colorless, and this is comparatively reactive. This is also paramagnetic in nature, and the reason is this is also containing single electron. And these two bonds are covalent bond, but this bond is coordinate bond. Nitrogen is using 2 electron for bond formation with for covalent bond formation with oxygen, and 2 electrons will be donated to oxygen because this bond is coordinate bond. So what is the difference between coordinate and covalent bond? If it is covalent bond, one electron is given by one atom, another electron given by another atom. But if it is coordinate bond, then both the electrons are given by one atom. So that is why it is also mentioned in this representation, by this representation. Okay, so arrow is from nitrogen towards oxygen because nitrogen has donated electron. So in this way, you can count how the that is total, how these 5 electrons are utilized. So this electron is single electron, sole electron. So because of presence of this electron, this is also odd electron molecule. So this one is odd electron molecule, this is also odd electron. And remember, this is diamagnetic, but the next two are paramagnetic. These are the important observations. Okay. When it reacts with water, it forms HNO2 and HNO3. That means if you are taking mixture of this acid, that is nitrous acid and nitric acid, and if you are removing water, then you will get NO2. That means it is anhydride of these two acids. Okay. Any doubt? Number 4, dinitrogen trioxide, N2O3. Now, the last oxide you have seen in the previous slide, NO2, which is brown colored gas, but this one is liquid. Boiling point very low, and it is dark blue color. How you can make it? Mixture of these two oxide at low temperature, it can form N2O3. But again, from low temperature, if you are increasing the temperature to room temperature, that is 25 degrees centigrade, again it will be broken. That means it is not very stable. It is unstable in the gaseous phase. It can also remain in solid state, and when reacts with water, it will form HNO2, nitrous acid. So this is actually the anhydride of nitrous acid. Now look at the structure. Here, two types of structure are given, though this is the main structure. Okay, there is presence of NN bond. See, the picture is also, you can see here. So this bond is basically coordinate bond. Nitrogen is using 2 electrons in the left hand side, oxygen, 1 electron in the right hand side, nitrogen, and 2 electrons remain out of 5 valence electrons. So these 2 electrons are used up because it has donated it to oxygen. So this bond is coordinate, and here we have presence of NN bond. Why this is important? Because sometimes it can be asked that in which oxide of nitrogen there is presence of NN bond. So N2O3 is one such oxide where NN bond is present. If you consider the previous oxides, here also NN bond is present. In which case? The first oxide, that is N2O. though it is that is multiple bond is present, but still NN bond is present. Okay. Then N2O4. This is actually the dimer of NO2, because we have seen NO2 is odd electron molecule. So that is the reason it has always a tendency to combine together so that it can form dinitrogen tetroxide. So 2NO2 molecule at low temperature, it is forming this dimer. See, this is the full structure. It has one lone pair and these two lone, sorry, it is not lone pair, it is a single lone electron. Okay. So these two lone electron together, it will make this NN bond. Colorless exist in equilibrium with NO2, both in gaseous and liquid state. In solid state, N2O4 is unstable. So whatever is the form, it is unstable because it has a tendency to break to the monomer. So this is the monomer. Fine. And here we can have two types of resonance structure. See. Now, why we are saying two types of resonance structure? Because both the structure are same. But actually, see, if you are numbering the oxygen 1, 2, 3, 4, now you can understand the difference. In the first structure, double bond is present between 1 oxygen, nitrogen, and 4 oxygen and nitrogen. But in the second structure, double bond is present between 3 and 2 oxygen, not 1 and 4. So that is the difference. Okay. So two resonance structures are there. And mostly it remains in this way where two double bond are opposite side. See, this NO double bond, both NO double bond, it is not present towards the same side. So this structure is actually not, we should not write it because it is unstable structure. Both the double bonds same side, that means there will be high repulsion between electron density. So that is why these two structures are actually more stable compared to this one. Then the last molecule N2O5, dinitrogen pentoxide, and this is the structure. Here we have two coordinate bond, and in this structure NON bond is present. So this can be another question: in which oxide NON bond is present? How you can make it? HNO3 nitric acid when reacts with phosphorus oxide P4O10, then N2O5 is produced. So that means P4O10, it has water attracting property. So if it is removing this water from HNO3 molecule, we can get N2O5. It has no existence in gas phase. In the solid state, it exists as nitronium nitrate. So see this N2O5, how it is remaining? It is remaining as NO2 plus NO3 minus. That means ionic in nature. There is cation, there is anion. So this is known as nitronium nitrate. But remember, this type of structure is possible only in solid state. Okay. So regarding oxides of nitrogen, is there any question? Now we will see question regarding nitrogen gas. We have to find the correct statement with respect to dinitrogen gas diatomic. The first statement, nitrogen is paramagnetic in nature. Now, if we consider single nitrogen atom, it has configuration, that is outermost configuration 2s2 2p3. But if you want to know that what is that is as a molecule, because N2 is diatomic molecule, it is not single nitrogen atom. As a molecule, is there any unpaired electron present or not? If we want to know that, for that we have to consider molecular orbital diagram. For nitrogen, this is the molecular orbital diagram. Here we have nitrogen atom, this is another nitrogen atom. So it is using 1s, there is 2 electron, 2s, there is 2 electron, and 2p3, 1s2, 2s2, 2p3. So 1s, there is 1 sigma bond, 1 sigma star, anti-bonding in nature. So there will be 2 electron, 2 electron. So total here we have 4 electron, 2 here, 2 here. So 4 electron. Similarly here also 2s2, 2s2, 2 electron satisfied. And here we have 3 electron. Now see, first there is pi 2px, pi 2py, pi bond. So that is why we have placed total 4 electron. And 3 plus 3, that means 6. Now Out of 6, 4 electrons already there, and 2 electron will be in sigma bonding, and this is sigma star, this is star. So here we do not have any unpaired electron. So nitrogen cannot be paramagnetic. It is diamagnetic. So the first statement, it is false. This is not correct. Next statement, it can combine with dioxygen at 25 degrees centigrade. Now remember, if you want nitrogen to react with oxygen, basically you have to break NN triple bond. You also have to break oxygen-oxygen double bond, and this requires high temperature. But here it is mentioned 25 degrees centigrade, which is room temperature, and this is not possible. Reaction is possible only at high temperature. So this is also not correct. Third statement, liquid dinitrogen is not used in cryosurgery. Now, cryosurgery means the surgery that is done under very low temperature. The word cryo is related to low temperature. Liquid nitrogen obviously can be used for low temperature because boiling point of nitrogen minus 195 degrees centigrade. So obviously it will be used in cryosurgery or any other low temperature process. So that is why this statement is not true, because it is mentioned is not used, but actually it can be used. So this is also false. So only one statement is remaining, and this should be the correct statement. What is mentioned here? Nitrogen can be used as an inert diluent for reactive chemicals. Inert diluent means what? It will help to dilute the mixture. So you are adding it, that is, suppose there is a reaction you are doing between A and B molecule, and you are getting AB. And this reaction you cannot perform in presence of oxygen. So the oxygen environment, that is air, must be replaced by nitrogen, so that there is only nitrogen atmosphere, and nitrogen is inert. It will not react with A or B. Okay, so that is why it is inert diluent. It is not just diluent, it is inert diluent, because itself is not taking part in reaction. So the last statement, that is actually correct, which is related to nitrogen gas. Now we have to find which statement will be wrong. So out of 4 statements, 1 statement will be wrong. The stability of hydrides increases for group 15 elements, obviously, from NH3 to BiH3 in group 15 of the periodic table. Now, what are the elements? Nitrogen, then phosphorus, arsenic, antimony, bismuth. Now, when we are talking about hydride, general formula EH3, and down the group, what is the stability? We have discussed in last class. When you are moving down, H is fixed, but the size of E is increasing. That means when size is very high, the distance between E and H, it will be very high. When E is very large, that means this bond is larger, you can easily break it. So down the group, stability of hydride will be decreased, because when you can easily break EH bond, that means its stability is not high. So stability of this hydride down the group decreases, it is not increases. Okay, so this statement is actually wrong statement, and that means it will be the correct statement. So if you are sure about this fact, even you don't have to consider the other 3 statements, and in this way you can save your time. Fine, but here we will also see the other statement. Nitrogen can't form d-pi-p-pi bond because it is from second period, and in second period there is no d orbital. So d-pi bond formation is not possible. And even if you consider that one element is nitrogen, another element is from third period, which is having D, but that is also not possible, because this is, it will use its 2p orbital, but 3p or 4p, it will be very large in size, there will be mismatching in size, so that is why d-pi-p-pi not possible. So this statement is true, nitrogen cannot form d-pi-p-pi. Then the third statement, single NN bond is weaker than single PP bond. If you consider this type of bond, obviously it is very strong. But when you are considering single bond, then obviously it is weaker than PP bond. So PP bond is basically more strong. This statement is also correct. And N2O4, remember, it is one of the oxide of nitrogen, which is basically dimer of NO2 that we have seen, 2 NO2 in equilibrium, N2O4. Now it has two resonance structure. These two resonance structure you have already seen, this type of resonance structure. So this statement is also correct. So only one statement is not correct, and that is option A. Is there any doubt? The set that represent pair of neutral oxide of nitrogen. Nitrogen oxide, different types of oxides are there, and if you want to know whether they are neutral or acidic in nature, basically you have to know the oxidation state. When oxidation state is high, acidic, it will be acidic in nature. If oxidation state is low, like +1 or +2, then it will be neutral. Here we have different combinations. Now look at this table. Here acidic property gradually decreasing. Now why it is so? Because here oxidation state is +1, then +2, +3, +4. This is also dimer of NO2, and this is +5. That means the first two are having very low oxidation number. This is also given here. So that is why it will be neutral in nature. Now when you are reaching intermediate oxidation state, that is +3, it is now gradually acidity is increased, but it is weakly acidic. Then the next two, where oxidation state is +4, it is acidic. And the last one, as it has maximum oxidation state, it will be strongly acidic. Now look at the combinations. Here it is +1, sorry, +2, +1. This is again the same molecule N2O, +3, again N2O, but this is +4, this is +2, this is +4. Now see, there are two compounds in each option. So only in the first one it is 2 and 1, then 1 and 3, then 1 and 4, then 2 and 4. So minimum oxidation state you can find only in the first option, NO and NO2, N2O, not NO2. NO and NO2, these two are neutral. So correct option would be option 1. Okay. Oxidation state of nitrogen in these four oxides, NO, NO2, N2O, NO3 minus, are in the order of. So there are different orders present. When it is NO, there is one oxygen atom, so obviously oxidation state will be +2. Two oxygen atom, it will be +4. Then one oxygen, it is +1, and NO3 minus. How to calculate? Suppose it is X. So X plus 3 oxygen atom, 3 into -2. Overall charge is -1. So it is X 6 minus 1, that means +5. So in this way you can calculate the oxidation state of NO3 minus, that is oxidation state of nitrogen in nitrate ion, it is +5. So maximum oxidation state for NO3. So NO3 will be at first, and that you can find only in option 1. So even if you are sure about the oxidation state of nitrate, then also you can easily choose the correct option. Okay, because NO3 is in other options, NO3 is present here in the second position, last position, this is also last position. So these three cannot be correct. NO3 minus, maximum oxidation state, then +4, +2, +1. Okay, so correct option is option 1. Should I repeat it once more? Is it fine? Both the problems are related to oxidation number. Is there any doubt? Next important molecule of nitrogen is ammonia. So here we have structure of ammonia. This is basically hydrate of nitrogen. This is pyramidal, and 3 NH bonds are there, and in the fourth position there is lone pair. Now we know that the standard angle in tetrahedral geometry is 109 degree. Okay, but here you can see that the angle is lesser than 109, that is a standard angle. This is 107.8 degree, and the reason is this angle is reduced from the standard value, and the reason is this lone pair bond pair repulsion. So there is electron present in NH bond and also in non-bonding electrons are there, that is lone pair. There will be repulsion between these two lone pair. As a result, the angle will be decreased. Fine. So smaller quantities of ammonia, if we want to make, it is present in air, okay, and also present in soil. And why it is present naturally in air and soil? It is because of the decay of nitrogenous organic matter. So by natural process, there is already presence of some ammonia. Okay. Now see, urea, when it reacts with water, there is formation of ammonium carbonate, but ultimately it is decomposed to ammonia. So this is the natural process that is going on in air or soil, and that is the reason naturally there is presence of ammonia, but in smaller quantities, obviously, in air or soil. If we want to make it on a small scale, then ammonium salts, caustic soda are made to react with each other. Instead of caustic soda, that is NaOH, you can also take calcium hydroxide. So NH4Cl calcium hydroxide, we are getting ammonia, water and calcium chloride. And if we want to make it in large scale, that is the commercial method, then we have to use Haber's process, where nitrogen gas and hydrogen gas are treated with each other, direct combination, but pressure should be very high, and there must be presence of catalyst like this, and this is known as Haber's process, which is very famous process for production of ammonia gas. So Haber's process, you can see the diagram. Nitrogen, which is we are taking from air, hydrogen we are taking from natural gas. Natural gas is mixture of CO and H2. Then there is a specific ratio 1:3. See, this is 1, this is 3. It is mixed. Temperature 400 to 450 degrees centigrade. Very, very high temperature. Look at the value, 200 atmosphere. And catalyst. Now, after this, the gases that will be produced, that is ammonia gas, it will be cooled, and it is cooled, that is why it will be turned to liquid. So it will be obtained in the form of in liquid condition. Right? Physical properties. It is colorless gas, though we have obtained it in liquid form, but that is only when if you are cooling it. But under normal condition, it is gas, and there is a specific smell. From smell also we can recognize ammonia, pungent smell. In its aqueous form means NH3 in presence of water, it will be NH4OH, ammonium hydroxide, that is the aqueous form. It is highly soluble in water, so that is why you can easily make NH4OH starting from ammonia gas. In its concentrated form, it is dangerous and also caustic in nature. Freezing point -77 degrees centigrade, boiling point -33.3 degrees centigrade. Okay, and in the solid and liquid state, there is presence of hydrogen bond, and that is the reason that it has high melting and boiling point. Remember, when we have compared the boiling point and melting point of group 15 hydrides, that is, I'm talking about ammonia, then PH3, then ASH3, what we have seen, we know that normally what happens, down the group, molecular weight is increasing, so van der Waals interaction will increase. So down the group, MP, BP both should be high and high as we are moving down the group. But ammonia, its melting point, boiling point values are such, it falls between arsenic H3 and SbH3. So PH3 will be having minimum MP and BP, and the reason is here hydrogen bond is present. So from molecular weight factor only, if you consider the MP and BP, it should not be so high. But because of this hydrogen bonding, it has higher melting and boiling. But don't think that it has negative value, then how it can be high. So when we are saying high, it is basically relatively high. That is, compared to the other hydrides of group 15, it is relatively high. So from its molecular mass, if you consider, it should be lesser value. That is, these two values are already negative, but remember, we are saying it higher. It is because of it is relatively high. Okay, so from its molecular mass, the MP and BP that you expect, it is actually higher than that, and that is because of the presence of hydrogen bond. It can be easily liquefied, which is clear from its critical temperature value. Now, when critical temperature is very high, what is critical temperature? The temperature above which liquefaction is not possible. Okay, that means if critical temperature is very high, that you are getting a long range in which the gas will remain in liquid state. So that is why it can be easily liquefied. Higher is the critical temperature, higher will easily it will be liquefied. So ammonia is having very high critical temperature, so you can liquefy it very easily. Detection of ammonia. So suppose you have unknown sample and you want to know whether it is ammonia or not. So for that, there is a specific reagent which is known as Nessler reagent. Nessler reagent, this is the formula, that is K plus AgI4 2 minus. So this will be actually 2 negative charge present here. That means Ag having oxidation state plus 2, 4 iodide, 2 negative charge extra. So it will be 2 potassium must be present to balance this charge. Fine. And in presence of ammonia, this type of complex is formed, and that is the reason ultimately there is formation of brown PPT. So detection, whenever we do any detection type of test, mainly there must be some visual color change or change in appearance. Okay, so here change in appearance we can find, and also color change, that is precipitation formation. So because of this precipitation formation, and also it is done under alkaline condition, and because of this precipitate which is having this type of structure, this is basically a complex, we will be able to understand that ammonia is present, because this type of PPT is formed only in presence of ammonia. Okay, so remember the name of the reagent is Nessler reagent. After physical properties, next we will see chemical properties. How ammonia reacts with acid, because ammonia itself is basic in nature, right? It is Lewis base because it has lone pair over nitrogen, and it can be donated to some electron deficient species, so that is why it is Lewis base. So because of its lone pair of electrons, it has Lewis basicity, and it has a tendency to act as Bronsted base also. So what is the difference between Lewis base and Bronsted base? There are actually different concepts for definition of base. One concept is Lewis base, where the definition is the tendency to donate lone pair. So if any molecule is having tendency to donate lone pair, you can call it Lewis base. But suppose if you are saying that if any compound or molecule, it has a tendency to accept H plus, then it will be Bronsted base. This is another definition of base. That means ammonia, it can donate lone pair to some electron deficient species, and ammonia, it can also accept H plus, and it will be, after accepting H plus, it will be converted to NH4 plus, that is ammonium ion. So both ways, whether you consider Bronsted concept or Lewis concept, from both point of view, it can act as base. Ammonia, when reacting with H2SO4, it is forming ammonium sulfate. So see, here it is converted to ammonium ion. That means it is acting as Bronsted base. Then ammonia reacting with HCl, it is forming NH4 plus Cl minus. So this is also Bronsted base. Okay, and so some reactions may be given in the question, and it can be asked that in which of this reaction ammonia is behaving as Bronsted base, or it is behaving as Lewis base. So this type of question you may get. But if we consider reaction between ammonia and Lewis acid like BF3, this type of molecule, then it will be simply donation of electron. So it is written like this. So in this case, it is behaving as Lewis base, but these two, it is behaving as Bronsted base. So this is the difference, because in BF3 there is no H plus. So how it will accept H plus? It has to give that is, it has to donate the lone pair of electron only. Okay. It has complex formation tendency because the lone pair that is present over nitrogen, this can be donated, so it can act as ligand. Okay, so this is a complexing agent. See, in presence of Cu2 plus ion, ammonia reacts and it forms CuNH3 whole 4 2 plus. So ammonia is neutral, so 4 ammonia when attached to copper, overall charge is also 2 plus. Then it can react with silver and it is forming AgNH3 whole 2. This is actually silver plus. Fine. So positive charge will be present here because ammonia is neutral. Here we have this reaction and see how the color is changing. So first there is presence of copper 2 plus, but it is written not as free copper 2 plus like this. It is, as it is aqueous solution, so 6 water molecules will be surrounding copper. So it is in aqueous state. Now copper 2 plus in aqueous state, it will have this type of specific color. And when we are adding small amount of ammonia, first there is appearance of some this type of gelatinous precipitate, and it is because of formation of this type of compound. So see here, out of 6 water molecule, 2 water molecule now OH, that means 2 hydrogens already taken by ammonia. So that is why now it is different structure. Next we are adding excess ammonia. Now what will happen? Water molecule will be replaced by ammonia molecule. So this is ligand exchange reaction. Now see here we have 4 ammonia molecule, 2 water molecule, and overall charge that is 2 plus present outside. Here also it is 2 plus charge because water are neutral, but here these 2 hydroxide, as it is negative charge, so this 2 plus charge is balanced by 2 HO minus, so that is why outside coordination sphere there is no charge. Okay, so finally the color is intense, it is now dark blue. So in this way you can understand that it is forming complex, because when it is simple Cu2 plus aqueous solution, there is light blue color, but when you are adding ammonia, now there is a color change. Similarly, if we consider Ag plus ion, so suppose we have solution of AgNO3 in this beaker and you are adding chloride solution, you can add NaCl solution, so there will be formation of AgCl precipitate. Okay, now if you are adding ammonia to this precipitate, okay, you are adding ammonia, what will happen? Ammonia will complex with Ag plus, so see it is AgNH3 whole 2 plus charge is there, and that plus charge is balanced by Cl minus. So ultimately, because of formation of this type of complex between AgCl and ammonia, this white colored PPT is now it is consumed, that is the PPT will be vanished. Okay, so first you have taken silver nitrate solution, that means you have taken Ag plus solution, you are adding chloride ion, there will be formation of AgCl, and if you are adding next ammonia, because of formation of this type of complex, now the PPT will be consumed, that is PPT will no longer be present, because PPT is because of AgCl, but if AgCl is not present, then PPT will also be not present. Okay, so this is the complex formation reaction of ammonia. Is it fine? Is there any doubt? Next is properties of ammonia. Some more chemical properties. Reaction with oxygen. When ammonia burns in air oxygen is there. So when heat is supplied, there will be burning of ammonia in presence of oxygen, and specific flame is produced, specific colored flame is produced, which is yellow-green. In presence of catalyst, ammonia is oxidized to nitric oxide. Okay, So different reaction condition, you will get different types of products. So when we are supplying heat, there will be burning of ammonia with green flame. In presence of catalyst, if we are using catalyst, then there will be formation of nitrogen, nitric oxide, and oxygen will be reduced to water. So see, now the reaction is different. So this is one condition where you are getting 4 ammonia, 3 oxygen, you are getting nitrogen gas and water. But in the second condition, we are using catalyst. Okay. In the first case, there is no catalyst. But in the second case, there is catalyst. Now the product is different. So it depends on whether you are using catalyst or not. Depending on that, different product you will get. Though it is reaction between ammonia and oxygen in both cases. Fine. Reaction with chlorine. Now this is very there is important observation, because product will be different depending on whether you have taken excess chlorine or you have taken excess ammonia. So the first reaction where we are using less ammonia but excess chlorine. See the ratio of moles, it is 2:3. So chlorine is present in higher amount. Now the product is NCl3, which is not very stable compound of nitrogen. It is yellow oily liquid and there is pungent odor. Another product is ACl. But now if we are using excess ammonia, this is the overall reaction, but it is mentioned in 2 steps. But if you look at the overall reaction, now the ratio, mole ratio is 8:3. That means ammonia is present in excess. Now the product is different. So when ammonia is excess, product is nitrogen gas and ammonium chloride. Okay. So this question related to this observation is very common, that what is the product of ammonia and chlorine, provided whether you have used excess chlorine or excess ammonia. So when it is excess chlorine, product is NCl3. When it is excess ammonia, product is nitrogen. Another product is HCl and H4Cl. Okay. Reaction with copper oxide. Ammonia reduces heated copper oxide. It is copper 2 oxide, because see the formula is CuO. It is not Cu2O. Cu2O is oxidation state +1, but it is +2. Reaction with ammonia, we are getting metallic copper, water, and nitrogen gas. That means here oxidation is it is reduction is taking place, because here oxidation state is +2, but here oxidation state is 0. That means from +2 to +2 to 0 oxidation state, this is reduction reaction. Okay. So we will end here. And regarding all the slides, is there any doubt? Should I repeat any part? In next class, we will see the uses of ammonia, and after that another important compound of nitrogen, which is HNO3, that will be discussed. So if there is no doubt, we were ending this session here. Thank you for listening.